Hello, B class and Chia, I believe, took this version of the test. Let me go through and see if I can replicate the key and give you some insight to what I was looking for on the test. So our first question is a piecewise function. We have a parabola and two lines. Lines and parabolas are continuous for all real numbers, but what we don't know is are they connecting at x equals 2 and at x equals 5? So we're going to find values of a and b, so it's a nice continuous function. So I can see that I already put back and forth between a couple of versions, so this should be a and this should be b, but hopefully that's my only typo and we can get going. All right, so let's take a limit as x approaches 2 from the left, and that would be that function, and we're going to see if that equals the limit as x approaches 2 from the right of the function below it. So I'm just going to put f of x here and plug in 2, and I get 4a plus 2 minus b. And I'm going to set that equal to the limit as x approaches 2 from the right. Again, plugging in 2 for x, I get 2a plus b. So I'm going to bank the equation 4a plus 2 minus b equals 2a plus b. And let's go ahead and simplify that. 2a minus 2b equals negative 2. And I can simplify that even more. A minus b equals negative 1. So we're going to bank that, and let's go to 5. Same deal. The limit as x approaches 5 from the left would be this equation. So I would have 5a plus b. And we're going to set that equal to the limit as x approaches 5 from the right. And that would be this equation. And so we plug in 5 and we get 10a minus 7. So 5a plus b, 10b, a plus b equals 10a minus 7. So negative 10a, negative 5a plus b equals negative 7. Solve this system and add them, and we get negative 4a equals negative 8, and a equals 2. Plugging in any equation we like, I'll probably go back up into this one. 2 minus b equals negative 1, negative b equals negative 3, so b equals 3. So if you got different answers for that, but you still took your a and b and plugged it up here, I followed your work and didn't take off more than the points that I took off here. But I did need to see both of these limit equations. So that makes my f of x to be 2x squared plus x minus 3, and then 2x minus 3, and 4x minus 7. So now let's evaluate the limit as x approaches 3. Well, where am I up here at 3? Well, I'm somewhere between 2 and 5, so I'm going to use my 2x minus 3. So the limit as x approaches 3 of 2x minus 3 is 6 minus 3, which is 3. Easy enough. The next one's a little bit trickier. X is approaching 1, so I'm definitely up here on this equation. So the limit as x approaches 1 of 2x squared plus x minus 3 over x minus 1. So let's see, I clearly have 0 in the denominator. In the numerator, do I have 0 as well? I do, so I need to take action. And if I factor this into 2x plus 3 and x minus 1, that's pretty good taking action if you ask me. Cancel out the 1's, and the limit as x approaches 1 is 5. Okay, let's keep going. Is f differentiable at 2? Justify your answer with a limit. So I'm going to pop back up here to the top and do a piecewise limit. So the derivative for x less than 2 is 4x plus 1. The derivative between 2 and 5 is 2. And the derivative between or greater than or equal to 5 is 4. And what I want to know is it differentiable at x equals 2. So that would be the limit of those derivatives from the left and from the right. So the limit as x approaches 2 from the left of 4x plus 1 is equal to 9. And the limit as x approaches 2 from the right, again, of the derivative. Well, that's a constant. And 9 does not equal to 4, so it's not differentiable. And there's my answer for that one. Let's go to the last problem where, as promised, I was going to give you a limit that was definition of the derivative. Right here is your f of x plus change of x minus the quantity of your f of x. So I'm identifying f of x to be 5 cosine x minus x to the 1/3. And so its derivative would be negative 5 sine of x minus 1/3 x to the negative 2/3. And there's our first page. Let's go to the second page where I gave you a table and I asked you a bunch of questions. Using the data on the table, find the average rate of change in temperature from 3 until 8. So that's going to be T of 8, which is 164, minus T of 3, which is 174, over 8 minus 3. We get 10 divided by 5, negative 10 divided by 5, which is negative 2. It makes sense that I'm cooling T, so the temperature is decreasing, so my rate of change should be negative, and my units would be degrees. Some people put degrees Fahrenheit. I took degrees per minute. Okay? Again, using the times identified in the table, the shortest interval during which there must exist a time for which the temperature is 166.5. Okay, so I see 166.5 between T of 6 and T of 8. Is this a continuous function? I don't believe if we're cooling T that you ever skip over a temperature. So I'm going to say that T of x is continuous. So by the intermediate value theorem, since T of 8 is less than 166.5 and T of 6 is greater than 166.5, and or you could actually say what those values are and then say that 166.5 is between them, then we can say that there does 166.5 degrees. Excuse me while I plug my computer in. Should brighten up the screen a little bit. There we go. And it's going to, come on, okay, exists over the interval from 6 to 8. I was looking for the 6 and the 8. I was looking for some kind of comparison. I was looking for the word continuous, and I was looking for a shout out to the intermediate value theorem. Use the data in the table. So again, some of you used values that you thought were on the table. You know, you kind of interpolated values, but I wanted you to just use what you were given. So if I want to approximate T prime of 4, I want to get as close of delta x approaching 0. Really, it's delta time, but I used x so we wouldn't have big T and little t. So let's go here to 4. To the left is delta x of 1. To the right is delta x of 2. So I see that these are the two values that I want to use. So 172 minus 174 over 4 minus 3 gives us negative 2. So that is my best estimate. And why? Because my change of x is approaching 0. That's as close to 0 as I could get. Some of you talked about the smallest interval, but again, we're talking about derivative here when we say instantaneous rate of change, and this describes what we want for a derivative to be a good estimate versus just a random estimate. I thought this last question was pretty straightforward. First of all, with the equation of the tangent line, we need to find f prime of x. You could also find f of 2, and when you put in 2, you get 1. So now we have the point 2, 1, and I can go ahead and load y minus 1 equals the slope times x minus 2. I'm just waiting to find the slope. F prime of x is 4, x squared minus 3 to the third, chain rule times 2x. Plugging in 2, we get 4 times 1 times 4, which is 16. And there is the slope of our tangent line. For what values of x does the graph of f have a horizontal tangent? Well, what is a horizontal tangent? It's when the slope is equal to 0. So I'm going to take my derivative. And the beautiful thing about my derivative is it's already factored. You don't have to expand it and then factor it to get it. You're just ready to go. So x squared minus 3 equals 0. X equals plus or minus root 3, and then from this parenthesis, x equals 0. So there were 3 horizontal tangents of this graph. Again, some of you went to great lengths to expand this when really all you needed here to get the second derivative was some simple chain and product rules. So I'm looking at this as being 1, and this as being 2. So here we go. 1, d2 plus 2, d1. Not forgetting my powers or this last little piece of chain rule. And again, no cleaning up, so I'm walking away from that problem. Here's what I ended up being the bonus. You did have a homework question that I went over in all 3 classes that was a lot messier. The only reason that I wanted you to sketch it was because I kind of wanted you to see what you were doing. You've got a parabola. You've got a point on the graph that's not on the parabola. And you can see that we probably have one tangent line going this way and one tangent line going that way. So that's why 2 tangent lines, I wanted it to be feasible for you to see what was going on. Okay, so old-fashioned slope. I'm just going to pick one of these points. This is the point x comma x squared. And this is the point 1 comma negative 3. What is the slope of that line? We could say that's x squared minus a negative 3 over x minus 1. Another way to express the slope of that tangent line in terms of x is to take the derivative of x squared and get 2x. If you cross multiply, you get 2x squared minus 2x equals x squared plus 3. So x squared minus 2x minus 3 equals 0. X minus 3, x plus 1 equals 0. So our values of x on that curve, on that parabola, are x equals 3 and x equals negative 1. You can use those x and y's. This would be what, 3, 9, and negative 1, 1. You can also use the common point and do point slope. And those of you that got it right, most of you used that point. The thing that you needed on both of these was the slope. Remember, a slope is the derivative, 2x. So here the slope is 6, and here the slope is negative, whoops, should do that vertically. Here the slope is 6, and here the slope is negative 2. So if you just want to take what you have there, you could say y minus 9 equals 6 times x minus 3. Then you can also go y minus 1 equals negative 2 times x plus 1. Again, I used the points on the curve. You could just as easily do point slope with this point, but the slopes have to be 6 and negative 2. If you didn't solve for them and you guessed them, you did not get the bonus, sorry. H, J, and K were all very straightforward, but a little bit conceptual because I didn't give you functions. So I'm just testing quotient rule. So H prime of x is low d high minus high d low over the square of what's below. And so you always need to do that first and then put the values in. So h prime of 2, let's see if I can scrunch this in here and read the chart right. G of 2 is 5, f prime of 2 is 1, minus f of 1 is negative 3, g prime of 2 is negative 2 over, what do we got there, 25, 5 squared. And you could leave it like that, obviously, but your answer was negative 1 over 25. 5 minus 6 over 25. J was a little bit of just chain rule, the definition of chain rule. J prime of x is f prime of g of x times g prime of x. J prime of 2 is equal to f prime of g of 2. So g of 2 is 5, and then g prime of 2 was negative 2. Finishing that up, f prime of 5 is 7. So 7 times negative 2. Again, I laughed when I saw people leave that, but again, I gave full credit for the correct numerical equivalent. The last one, again, was chain rule. It just kind of is coming at you with an outside function that's defined square root. So k prime of x is 1/2 f of x to the negative 1/2 times f prime of x. So let's plug that in. K prime of 2 is equal to 1/2, and then 1 over, because of the negative exponent, f of 2 is, why am I not finding f of 2? Oh, sorry, this is asking for 5. That's why I was trying to stick a negative under the radical. There we go. So k prime of 5, we take the square root of 4, and then times f prime of 5, and f prime of 5 is 7. Again, you could leave it like that, or you could clean it up into 7/4. One very straightforward, in which I must say you all did extremely well on, was our implicit. So doing this the way I taught you, 6y squared dy. This is definitely product rule, so I'm going to remind myself of that. So I'm going to let negative 3x be 1 and y be 2. Some of you factored a negative 3 out, and that might not be a bad thing as long as you remembered to distribute it back in. So I've got 1 d2 plus 2 d1. So that negative 3x becomes negative 3 dx plus 2x dx, and the derivative of 4 is 0. Dividing through by dx. So my first two terms have my dy dx in them, so I'm going to factor that out. Taking the other two to the other side, I have 3y minus 2x, and my final answer is dy dx equals 3y minus 2x divided by 6y squared minus 3x. And here's the home stretch, page 4. So, given a function that's defined by the product of f of x times tangent x, where f is differentiable for all x, so, you don't have to really worry about f. I want to know in A for what values of x, if any, over the interval 0 to 2 pi, will the derivative of g fail to exist? Justify your answer. So the first thing that I'm going to do is see if there is any place on G where it's not continuous. Well, f is differentiable, so it's continuous. I'm done with f. Again, I'm just going to look at tangent. Tangent is, if you have problems remembering, sine over cosine. And so tangent is not continuous where cosine is equal to 0, and that is pi halves and 3 pi halves. Okay, so it would be these values because G is not continuous. Now, I also need to check differentiability. So somewhere between A and B, and I kind of just lumped it together, I needed to see a G prime of x. So G prime of x is 1. Derivative of tangent is secant squared plus tangent times f prime. Checking differentiability means you need to take a derivative somewhere and see if it fails to exist. We've already found where tangent fails to exist, so we don't need to do that again. Secant is 1 over cosine squared. And honestly, we took care of that up here when we set cosine equal to 0. So there we're done. It's just pi halves and 3 pi halves because the continuity and differentiability hit the same points. G prime, okay, so I've already done G prime of x, so let's do G prime of pi fourths. So we've got f of pi fourths, which is 4 from up above. Secant squared of pi fourths. Here's where I'm kind of putting your knowledge of the unit circle to the test. Cosine is 1 over square root of 2, so secant is the reciprocal, which is square root of 2 over 1 squared, plus tangent of pi fourths, which is 1, and then f prime of pi fourths is negative 2. So it looks like I have 4 times 2 minus 2, which is 6. And that is it. Please come and see me if you have any other questions. And I will see you next week.